revise what we have studied actually. Uh, See, we yesterday we completed the chapter called S block elements. Now, some of the portions which is left, let us move forward into the equilibrium. So, we studied about pH scale, and we have seen that in a pH scale we have, or actually when we call pH scale, we generally have pH, pOH, pKw, concentration of H plus and concentration of OH minus, everything included into it. So that is how we studied about the pH scale. Now when it comes to the pH scale, you can see that we have few important formula that pH plus pOH is equal to 14 is equal to pKw, and we even have this formula, or we even have this calculation that the concentration of H plus into the concentration of OH minus is equal to 10 to the power minus 14, which is, we also call it as a KW. So this is how, my dear students, we understand and study the pH scale in detail. We then, my dear students, we simply become aware that pKw is a very important quantity for aqueous solution and controls the relative concentration of the hydrogen and hydroxyl ions as their product is a constant. Please note that pH scale is logarithmic scale. A change in pH by just 1 unit also means change in H plus by the factor of 10. When hydrogen ion concentration changes, that means concentration of H plus changes by a factor of 100, the value of pH changes by 2 units only. Now we realize why change in pH with change in temperature is often ignored. So the change in temperature when the temperature changes, concentration of H plus changes in a very small quantity that does not affect the pH much, and that is why we generally avoid it, or we generally do not take it for the consideration. Measurement of pH of a solution is very essential as its value should be known when dealing with the biological and cosmetic appliances. So my dear students, when it comes to the chemicals that needs to be used for the living organisms, uh, the pH of those chemicals has to be taken into the consideration, and they should be prepared in a certain pH range only. So whenever we have biological or cosmetic appliances, their pH has to be taken care. Now my dear students, we want to study about the pH paper. Dear student, I would like to show you the pH paper first, and then we can move forward. What kind of pH paper do we have? So I'm going to unmute my. I'm going to show you the uh, pH paper in a well manner. You can see now you have a paper. This is what it is known as the pH paper. See, when we have pH paper, actually we have this kind of marking on its paper, so that we can realize that what color, and on the basis of these various colors that we have, we can even mark um, uh, the pH of a particular given solution. So, my dear students, you can easily see here. This is your pH paper marking, and on the basis of the color, when we compare this color of pH paper, we can come to know about the pH of a particular solution. Here you can see that this is what it is, the pH paper, and when I break it this way, we get a strip of pH paper. This is my pH paper. Now I shall dip it into the various solutions so that we can come to know that what is the color we get, and then we will compare and we will measure the pH of a particular solution. Let me start with this solution first. I'm going to dip this pH paper. You can see, I hope you can see the pH paper dipping into it. Now you can see the color of the pH paper. The color of the pH paper, it has been changed. Now you can compare this color of the pH paper with the pH here. Can you tell me what is the pH? Dear students, I am asking, what is an approximately pH of this? I think it's difficult for you. Is it really difficult? What color matches and what could be the pH?
12.
Very good, you are right. Speak little louder.
12, sir.
Very good, very good. So you can see now that you can just simply come to know that this particular solution has its pH 12. I hope you enjoyed. Very good. I am so happy that you come to know about the pH. Now I am going to give you another solution on the basis of which we can understand the pH. This is the solution. I am going to dip the pH paper into it. You can see the pH paper. I am dipping it. And now I have just removed it from the, now can you see any color on it? Dear students, are you able to see any color? बच्चों, आपको कोई कलर चेंज दिख रहा है?
Yes,
Please
sir.
बताइए, हाँ, क्या कलर दिख रहा है? What kind of
Yes,
color
sir.
you can see on the pH paper now?
Blue.
Think once again and see, my dear child. Is it blue?
No, sir.
Then what color can you see? Let me do it once again for you. I hope you guys are still confused. Please watch. Everybody and everybody should participate and tell me the exact idea. Please do not. You should understand the color change, my dear student. Can you see the color? What kind of color is it? Okay, let us compare it with the pH paper and you will come to know. Can you tell me the pH of this? Dear students?
8.
Sir, 8 or 9.
8 or 9.
8 or 9.
Okay, do you understand? Can we say it's 7 or not? Not similar to 7.
Yes, sir.
Don't do it that way, my dear student. But fine, no problem. So, but let us say it is according to your, what is the pH, my dear student? Can you tell me the pH? Because I have dipped this solution into water. Is it similar to 7, 8 or 9?
7.
See, I think due to the camera, the color change, you are not able to observe it well. Sitting far away, you cannot observe the color well, but the color is very similar to 7. It's a green color, my dear student. Okay, got it?
Yes, sir.
Thank you. Now let's move and understand the next one. See, I'm going to dip this pH paper, but still you can come to know about the pH. You can easily say it was 7 or 8 or 9, something like that. Now I'm going to dip this pH paper into this solution. Can you see the color change?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Can
sir.
you tell me what is the pH of the solution? Just 1 minute. I'll have to hold it this way.
So this
Three.
is 2.
So you can say it either it's everybody, please.
3. No, sir. 1. 1.
5.
Say,
One,
Five.
it is 1.
1.
It should be 3 because it's similar to 3, or we can say it is 1, but 1 requires very dark color. Let's say it's 3. So this is the important practical even in your syllabus where you just identify the pH of a given solution using the pH paper. I hope it is understood, dear students.
Yes,
Hello?
sir.
Yes, sir.
Yeah. So now this is what it was pH paper, and this is how we perform an experiment. Let us move forward and understand what is written over here, and you will be easily come to know about the pH. So the pH of a solution is found roughly with the help of the pH paper that has different color in solution of different pH. Nowadays, pH paper is available with 4 strips. So you can see that we can understand the pH of the solution using the pH paper. Nowadays, pH paper is available with 4 strips. The different strips has a different color at given pH at the same pH. The pH in a range of 1 to 14 can be determined with the accuracy of 0.05 using pH paper. So my dear students, the pH what you have been telling around 8 was approximately 7 point something, and that is why, and due to even the color that we have limitation of camera, but wonderful to see that you have answered all the questions and you could realize that we can measure the pH. Now you can see here, suppose we have a pH paper which is very advanced pH paper which is known as the 4-strip pH paper. Then you can see that you will, on pH paper you will get 4 different colors, and if you have 0 pH you will get this kind of colors on the if you have 1 pH this kind of color, 2 pH, 3 pH, 4 pH, 5 pH, 6 pH, 7 pH, 8 pH. Now if you can see, actually the color what it was looking to me when I'm sitting in front of here, it was this. So this is how, let me start, this is the color I was able to see. Let me show you 1 second, maybe you realize it. Can you see the similar color, dear student? Can you
Yes,
see?
sir.
Yes, sir.
Yes or no? I hope you understand it.
Yes, sir.
The color was similar to that which was under 7, that is what I feel. Maybe it is 8 roughly around because the water may be, but let us say because I have used this water here and generally the water shows the pH of 7. But whatever you observe is correct, no problem. Let's move forward. Then if we have 8, which this is the kind of, then 9 and 10, then 11 and 12 and 13 and 14. And this is how, my dear student, we understand the pH paper with 4 strips that may have different colors at the same pH. Now let's move and understand the next one. Let us study about pH meter. there is a device which is also known as the pH meter. For greater accuracy, pH meters are used, my dear students. pH meter is a device that measures the pH dependent electrical potential of the test solution within the 0.001 precision. So if we use pH paper, we will come to know the pH exactly. pH meter with the size of writing pens are also available in the market. So my dear students, this is the photo I have taken of the pH paper that I have in the lab. This is the pH paper. This is the something like screwdriver that is used to calibrate the pH meter, and this is the pH meter. This black cover, we remove it, and then we use this pH meter. You can see it again. This is the pH meter. Here we can read the reading, and this is how we can calibrate it. You can see that it is the size of the pen. Now this is what it is, the bulb that measures. When we remove the black cover, this is what it is, the bulb that actually measures the pH. And pH is noted into the reading, my dear students. You can see here, I have a picture of your pH meter. You can see that in pH meter, these are the on-off switch. This is the battery compartment up to here. Then this is the liquid crystal display where we can find out the pH. And this is the maximum storage level, and this is the minimum storage level. This is the bulb which measures the pH. That is what I have shown you. So I hope, my dear students, you understood about the pH meter and pH paper. Do you have any doubt? You can ask me, dear students.
No, sir.
Understood
No, sir.
everything?
No, sir.
No, sir.
Sure?
Yes, sir.
Yes,
Okay,
sir.
then
Yes,
let's
sir.
move forward and understand something else. So, my dear students, we have just studied about the pH meter. pH meter, for greater accuracy of pH, we use this pH meter, my dear students, as you are well aware. So, for greater accuracy, we use pH meter. pH meter is a device. pH meter is a device that measures the pH dependent electrical potential. That is what we have seen already. Now let us study, my dear students, some questions. So what is the next question? The concentration of hydrogen ion in a sample of soft drink is 3.8 into 10 to the power minus 3 mole per liter. What is its pH? So now we are going to learn how we can calculate the pH. Now you can see that the hydrogen ion concentration is given, that is 3.8 into 10 to the power minus 3 mole per liter. So this is what we can write, that H plus concentration is equal to 3.8 into 10 to the power minus 3 mole per liter. We have the formula that pH is equal to minus log of H plus. So pH is equal to minus log into 3.8 into 10 to the power minus 3. My dear students, if you have log of A into B, you simply write it as a log of A plus log of B. So you have written it here, minus is outside the bracket, log of 3.8 plus log of 10 to the power minus 3. Now if you have, my dear students, if you have log of A raised to x, then you simply write it as x log of A. So here you have written log of 10 to the power minus 3, that you can write it as a minus 3 log of 10. My dear students, log of 10 is equal to 1. And that is why this gives us the answer minus 3. Log of 3.8 is equal to 0.58, my dear students. And thus finally we get the pH of the solution 2.42. So this is how, my dear students, using the formula pH is equal to minus log of H plus concentration. We can find out the pH. Sometime instead of H plus, we can even write minus log of H3O plus. Therefore, the pH of the soft drink is 2.42 and it can be inferred that it is acidic in nature, because when the pH is less than 7, we can say that it is acidic in nature. Now we have the next question to be solved. The next question says that calculate the pH of 1 into 10 to the power minus 8 molar solution of HCl. So now let us calculate. You can see that 2H2O, that gives us H3O plus and OH minus. Kw is equal to OH minus into H3O plus, that is 10 to the power minus 14. Now you can see here the concentration is 10 to the power minus 8 order. Generally, when you have concentration of 10 to the power minus 7, you can say it's a neutral. But here it is actually in the basic side, because it is 10 to the power minus 8. That is what we have studied in the pH scale. So here, my dear students, X is equal to OH minus concentration is equal to H3O plus concentration. So let us say the concentration of OH minus and H3O from the ionization of HCl dissolved. Now what is your X? X is equal to the concentration of H3O plus done to self-ionization of water before adding HCl. So my dear students, you can easily understand that there was a vessel in which we initially had a water. In this water there was some ionization of water itself, and then we from outside we add HCl. This is what it happens. And when we add HCl, the pH of this particular solution is changed. And the solution is now 1.0 into 10 to the power minus 8. So let us say X is the concentration of the solution or concentration of H plus when HCl was not added. Now what happens? The HCl is added to such a small quantity that the concentration become 1.0 into 10 to the power minus 8. So what happens, my dear students? The HCl plus H2O, that gives H3O plus and Cl minus. This HCl actually ionizes to H plus and Cl minus, and that is how we get H3O plus and Cl minus. So total concentration of H3O plus would be X plus 10 to the power minus 8, because 10 to the power minus 8 is the solution of HCl that we have added to it. So now the total concentration of H3O plus was X, which was available initially when HCl was not added. So when HCl was not added, my dear students, X is the concentration of H3O plus in the solution. Then we have added HCl, so the new concentration become 10 to the power minus 8. So this is how we can say that the total H3O plus concentration is X plus 10 to the power minus 8, because this is the concentration of HCl. So now what happens? Kw is equal to 10 to the power minus 8 plus X into X, that is equal to 10 to the power minus 14. Now why do we do it? This is the concentration of H3O plus and X is the concentration of OH minus, because in water the concentration of H3O plus and OH minus should be equal. Here you can see that when water dissociates, it gives H3O plus and OH minus. And suppose if the concentration initially was C for water, let us say the concentration was C for water, then initially it is 0 and 0, but later on at equilibrium this becomes C into, this simply becomes C into C minus C alpha, and the concentration of H3O plus would be C alpha and concentration of OH minus would be C alpha. On that basis we can say that concentration of H3O plus and OH minus are equal after ionization. So that is why if the concentration of H3O plus before addition of HCl it was X, then the concentration of OH minus at that time should also be is equal to X. So here we can take, we are well aware that Kw is equal to the concentration of H plus multiplied by the concentration of OH minus. Now the concentration of H plus is 10 to the power minus 8 plus X, and concentration of OH minus is X, that is equal to 10 to the power minus 14. Therefore, 10 to the power minus 8 x plus x square is equal to 10 to the power minus 14. By multiplying both this bracket, we get this. And then we can finally get this equation x square plus 10 to the power minus 8x minus 10 to the power minus 14 is equal to 0. Now by solving this equation for x, my dear students, we get the value of x is equal to 9.5 into 10 to the power minus 8. My dear students, if you find it difficult to calculate this value, I have done it for you, my dear students. Here I have shown you how you can calculate it, but we are not going to discuss it because it's a mathematical steps that I have done. But for your compliance or for you to understand it well, I have shown on the next pages, and these pages I have already sent to you so that you can study it from here. This is what the calculation I have done it for you so that you can understand how do we get this value of x. So let us move forward and understand that here this value x is equal to 9.5 into 10 to the power minus 8. How do we get that calculation? I have already shown you, and these notes have already been sent to you so that you can understand it well. So we get the value of x is equal to 9.5 into 10 to the power minus 8, and therefore the concentration of OH minus is equal to 9.5 into 10 to the power minus 8. We know that POH is equal to minus log of 9.5 into 10 to the power minus 8, which is 7.02. We know that pH plus POH is equal to 14, and by putting the value of this POH 7.02 plus pH is equal to 14, and that is why your pH would be 14 minus 7.02, and this is how you do the subtraction, my dear students, and you get 6.98 pH for this solution. So let us look into that. That pH plus pOH is equal to 14, and that is why pH plus 7.02 is equal to 14, and that is why pH is equal to 6.98. Here I have shown you the calculation how you can get the value of x into the particular problem. So for that I have done it for you so that you can understand it well if you could not understand the mathematics well. Now let's move forward and understand the next one. Let us study about the ionization constant of weak acid. So here we learn how we can calculate the pH of a particular solution. Now we want to study about the ionization constant of the weak acid. Let's move forward and study. A weak acid HX that is partially ionized in the aqueous solution, the equilibrium can be expressed by this way. So we have a weak acid HX. It was added to H2O, so we get H3O plus and X minus. Remember, this acid is weak, and that is why it is partially dissociated. It is not completely dissociated, but it is dissociated partially. So now let us understand here. Now what happens? We write this equation and then we understand. Suppose initially there was C mole per liter of HX available. So there was no product initially, so the concentration of H3O plus and X minus is considered to be 0. If alpha, this is what I have called it alpha. If alpha is the degree of dissociation or extent of ionization, then change in the concentration. Suppose alpha is the degree of dissociation. So if you take 1 mole, my dear students, the change is alpha. If you take 2 mole, the change is 2 alpha. If you take 3 mole, the change is 3 alpha. If you take C mole, the change is C alpha. As the concentration of reactant decreases, the change is minus C alpha. But the concentration of product increases, and that is why the change is plus C alpha. You can see that the stoichiometric coefficient for them is 1, and that is why we have written 1 alpha, 1 alpha. Suppose the stoichiometric coefficient here 2, then you need to write 2 alpha here, 2 C alpha. If the stoichiometric coefficient for this, suppose it is 1 by 2, then we should find the product 1 by 2 C alpha. So this is how we understand, my dear student, that the change takes place. So you can see that the reactants have change which is negative because their concentration decreases, but the products will have the change which is positive because concentration increases. So now at equilibrium, my dear students, what is the total concentration? So initially the concentration was C, minus C alpha has been the change that has been taken place. Initially the concentration was 0 and plus C alpha, that is the change. Initially the concentration was 0 and plus C alpha is the change. So finally, if we take C common from this, then we get C into 1 minus alpha. That is the concentration at equilibrium for our acid HX. Same way, the concentration of H3O plus is C alpha, and the concentration of OH minus is, sorry, and the concentration of X minus is C alpha. So this is how we understand. Now please remember that C is known as the initial concentration of undissociated acid HX at the time is equal to T. When we say time is equal to T is equal to 0, that means it was the initial situation. Alpha is known as the extent up to which HX is ionized into ions. It is also known as the degree of dissociation or degree of ionization. Using this information, we write the equilibrium constant. So let us write the equilibrium constant because we know how to write the equilibrium constant. The equilibrium constant is written by taking the product of the concentration is to the product of the reactants. So for this equation, we can write, what was the equation? HX plus H2O, that gives us H3O plus and X minus. So these are the products. So we take the product of the concentration of products is to, that is division, is to the concentration of reactants of is to the product of the concentration of the reactants. Now concentration of water in liquid state considered to be constant. So multiplying it with K, we will get K into H2O is equal to H3O plus multiplied by X minus divided by HX. Now for this K into H2O, we get or we introduce the new equilibrium constant, which we call it as a Ka. That is what the Ka is known as the dissociation constant of acid Ha, or it can be the ionization constant for an acid. So now we can write that Ka is equal to concentration of H3O plus multiplied by the concentration of X minus divided by the concentration of HX. Please remember that whenever we write K for a given equation, which was similar to this, we do not consider the concentration of water into the denominator, and whenever we write K, we will not write the concentration of water here because K is already K into concentration of H2O. So this is something I would like you to know about. Now we know that the concentration of H3O plus is equal to C alpha. The concentration of X minus is C alpha. And for HX we can write C into 1 minus alpha. I hope you can recall it. If not, let me make you understand it once again. Or you can see it here. You can see that the concentration of our HX was considered to be C into 1 minus alpha. This is the concentration of H3O plus and this is the concentration of A minus. So concentration of H3O plus is C alpha, concentration of A minus is C alpha, and concentration of HX is equal to C into 1 minus alpha, that we have already seen, my dear student. So we put those values over here. And then when we put these values, C alpha divided by C into 1 minus alpha, we can write it as C square alpha square divided by C into 1 minus alpha. And finally, we get K is equal to C alpha square divided by 1 minus alpha. Now for weak acid, if the acid is weak, my dear students, the degree of ionization or degree of dissociation, alpha is very small as compared to 1. So we can say 1 is far bigger than alpha, and that is why 1 minus alpha is equal to 1. So if it for a weak acid, if we take, see, remember, for a weak acid, if we take, I'm speaking very clearly, if we take 1 minus alpha is equal to 1, we can, if we take 1 minus alpha is equal to 1, we can write Ka is equal to C alpha square divided by 1. Therefore, your Ka is equal to C alpha square, and therefore your alpha square is equal to